We're going to start in Chapter 1 with functions. This is going to go on page 2 of your interactive notebook. If you remember from Algebra 1, a function is a relation in which every input has exactly one output. So that means for every element in the domain, it can only have one single element that pairs up with it in the range. Just a note is that all functions are relations, but the vice versa of that is not true. All relations are not functions. I'll give you a couple examples of that in just a moment. Two of the characteristics of functions. The first is that each function will pass the vertical line test when you graph it. In addition, each input will not repeat. That means for every element in the domain, you will only see it once in the ordered pairs, and you'll never see another one that repeats. The output, however, can. An example of a function, I have a graph here. So if we were to do the vertical line test on this, none of the lines would pass these points more than one time. In the ordered pairs, you can see that each of the domain or the input don't repeat. They all have one single y value to go with them. Some non-examples of functions. We have one that's a table and one that's a mapping. These are both relations. So these two examples of relations are not functions. In the first one, with the table, looking at the input, you'll see that the number 4 pairs up twice with two different y values. 4 goes with 7, and it also goes with 2. That means it cannot be a function because the input repeats. And in the second one, this is a mapping. On the left-hand side, you'll have your input, and on the right-hand side, you'll have your output. The arrows represent the relationship between the two sets of numbers. So for example, 2, 1 would be an ordered pair, and 2, 0 would also be a ordered pair. 4, 3, and 7, 2 would be the last two ordered pairs. So in this case, you'll notice that 2 gets paired up with two different numbers, the number 1 and the number 0. As a result, this is an example of a non-function, but it is still a relation. We can look at some equations as well to see what kinds of equations, what they would look like whenever you're looking at, for functions. The first one we have is y equals x squared. You can actually use any other even number for the exponent, and when you go to graph this, it'll look like a parabola, and it points upwards. A parabola, you know, passes the vertical line test, so this is going to be an example of a function as a equation. And then we also have y equals absolute value of x. This is going to be the shape of a V, and this also passes the vertical line test. Now, the other two examples look just like these. These are going to be our two non-examples, but you'll notice that I switched the x and the y on this first one. So we now have x equal to y squared. So to show you why this would be a non-example, if you plug in x equals 4 into the output, you will notice that there will be two different inputs that you get for that, 2 and -2. So we'll have 4, 2 and 4, -2. As a result here, these two 4s repeat, and therefore this cannot be a function. I think I may have switched my input and output word. The 4 should have been the input and the 2 should have been the output, so I apologize if I mixed that up just now. Also, when you switch these x's and y's, you'll notice that the parabola is no longer facing up and down, but left and right. So this certainly does not pass the vertical line test. If we wanted to solve for y, we would simply take the square root of both sides. When you take the square root of both sides, you would have to put a plus and a minus symbol. And the reason for this is that when you square both sides of this, the positive and the negative would both go away with the squared, and you would get the square root of x squared, which would become x, and the negative square root of x squared, which is still x as well, and those would both be equal to y squared. And finally, in the second example, that's a non-example, if you switch x and y, we would have, for an example for the ordered pairs, is 3 for the x, the input. And so if I plug in the number 3 here, I can get both either 3 or -3 for the output when you take the absolute value. As a result, the x's repeat, so therefore this cannot be a function. Also, when you switch your x and y, you get a sideways V shape, which does not pass the vertical line test. And finally, if you wanted to solve for y, you would take the absolute value, so you already have the absolute value, so in order to drop that, you would have to put a plus and a minus x, because x could have been positive or negative to giving you that positive y value. Okay, and that's all for page 2 on the definition and characteristics of functions.